I'm going to breeze through the math on most of this to make this a quick video because for the most part it's just high school algebra. I saw this problem on YouTube. Someone gave it as an example of how to use calculus in the real world, and I thought this looked like a great starter problem to show somebody how calculus is used and how to set up the equations. I didn't see it solved, so I thought this would be just a fun kind of a brain teaser or a fun equation to try to solve. And then if I can post this and other people see it, then everybody can see actually how easy calculus is and how it's actually just mostly algebra. So in our example here, we're working in a factory and these machines are cranking out millions of these sheets. They could be sheets of cardboard or sheets of metal or plastic or whatever. We have to cut the corners out so we can flip up the edges to turn this into a box. And because we're making millions of these, we want to be the most efficient and give these boxes the greatest volume. One way to do this without calculus is just start cutting off the corners with different values for x and fill your box up with water to see which boxes have the most volume. But if you want to do this a more sophisticated way, you can use some just simple calculus. And that seems like an oxymoron, but I'll show actually how easy this can be. The length of our box, or at least the length of our sheets, will be 10 by 5. So the length of the box will be 10 minus this x minus that x. So 10 minus 2x will be the length of the box. The width of the box will be 5 minus 2x for the width right there. And then x right here will be the height, because after we cut these corners off, we flip this up and it'll have x as a height right there. For any container, like a box or a rectangle or whatever, just multiply all of its dimensions to get its volume right here. So go through and FOIL this out, multiply everything by x. It'll all look like this right there. If you want to graph this out by plugging in a bunch of random numbers, you're going to notice a peak here and a valley here. The x component determines, going across the x-axis will determine what our x value is here. The y component will give us the volume of the box. So we plug in our x's to get our y, which equals volume. We want where that peak is right there. In other words, we want that slope to be 0, the slope of that line. So we want it to be horizontal. As you draw a line, a tangent line that touches these curves here, that line will get more and more horizontal until it's at the very peak here, and then the line will get steeper going the other direction. We're not interested in the valley here down in the negative y direction. We just want this one. If you plug the formula into a graphing calculator, it'll highlight your peaks and it'll tell you where x will equal, you'll get x of 1.05 right here for your peak, and x equals 3.9 for your valley right there. It also gives the y coordinates, but I didn't write those down. To take the derivative of something, anybody can do. You just bring your exponent down, multiply it by your coefficient. 3 times 4 is 12. Subtract 1 from your exponent. There you go. That's the equation for the slope of a line at a curve. We want that slope to be 0, as I just illustrated. Because we want it to be horizontal, that means we're at the peak. Go through the quadratic formula to get our values of x equals 3.9 and 1.06. Plug 1.06 and 3.9 into your original equation, which is right here. You're going to get 24 and negative 24. This means if x equals 1.06, your y, which is your volume, will equal 24, and that's your peak. To do this the old-fashioned way without the graphing calculator, plug some numbers in between. So a number before 1.06, a number between the 1 and 3, and then a number after 3.9, and see what your values are to give you an idea if you truly are at the peak and valley. And that's it. That's calculus. 99% of it's algebra, and with a lot of several pages of problems where you have lots and lots of chances to make errors. So that's the saying I've heard for years is go to calculus to fail algebra. But if you get all your algebra right, then you'll get the right answer. Plug in 1.06 and you'll get maximum volume and maximum value for your box right there.